Welcome back to the wonderful world of pre-calc. Today we are doing the last section in the first part of Unit 2, which is 2.5, and it's the fundamental theorem of algebra. We have 4 objectives today. The first thing that we're going to look at is we're going to use the fundamental theorem of algebra to determine the number of zeros of a polynomial. Zeros of a polynomial. Okay, so how many times does a polynomial cross the x-axis? I should say if they're real zeros, right, then they cross the x-axis. If they're complex zeros, then they don't. Okay, so objective number 2 is to find all of the zeros of a polynomial function, including complex zeros. So complex zeros are zeros, but they don't physically cross the x-axis because they're imaginary, right? Part 3 is we're going to look at finding the conjugate pairs of complex zeros. So remember, conjugates are those terms that are 2x plus 1, 2x minus 1, right? 1 plus, 1 minus, but the terms are the same. And then our last step is to find all the zeros of polynomials by factoring. So we're going to look at factoring today. We're going to look at synthetic division. We're going to look at multiplying, okay? The good news is that none of the math today is new. Like all of the calculations and things we know how to do already. It's just kind of taking all of these pieces that we've looked at individually and putting them together into one problem. So we're going to start with looking at the fundamental theorem of algebra. Wow, by the end of the day, I cannot talk. Okay, so the fundamental theorem of algebra states that if I have a polynomial, f of x, with degree of n, as long as it's bigger than 1, bigger than or equal to 1. So if the degree is 4 or the degree is 5 or whatever, right? Then the equation has at least one complex root. Okay, so there's at least one complex root if I set the equation equal to 0. Okay. Other things there, so whatever my degree is, that's how many roots I have. Whether those roots are real or complex depends on the problem. But if I have a 4th degree, there are 4 roots. If I have a 10th degree, there are 10 roots, right? If I have a 150th degree, there's 150 roots. Okay, then the other thing to note is if I have a complex root, a plus bi, if that's one of my roots, if that's one of my parentheses, then automatically a minus bi is also a root. Okay, so if I tell you that 2 minus 4i is a root, then 2 plus 4i is automatically a root, whether or not I've told you so, okay? So those are the 2 kind of like key things. If we look at the linear factorization theorem, all this says, so don't worry about it too much, but all it says is if I have a polynomial with degree n, as long as that degree is greater than 1, or greater than or equal to 1, okay, then I can split this into factors, and it's called linear factors, okay, and it just means, okay, x plus 1, x minus 7, 2x plus 3, x minus 4, right? Those 4 things are my linear factorization, okay? So whatever my degree is, I can break that into that many parentheses, that many linear factors. So we're just going to look at a couple examples here, and we're just going to get going into it, mainly because you guys know how to do all the math on these already. It's just, like I said, putting multiple things together. Okay, so example 1 says, counting multiplicity, confirm that the 2nd degree polynomial function f of x equals x squared minus 6x plus 9 has exactly 2 zeros. Okay, well, I'm lucky here because automatically I see that this is something that I can factor. Okay, so this factors into x minus 3 times x minus 3. Okay, so this graph, we can also write it as x minus 3 squared, right? Since it's the same thing written twice. So this tells me that x is equal to 3. So this crosses the x-axis at 3, and the multiplicity is 2, which remember means it bounces off the x-axis. Well, since the multiplicity is 2, you can count this twice. So there are 2 zeros, right? One at 3, and the other one is also at 3. So because of the multiplicity of 2, you get to count that twice. So we've showed that x squared minus 6x plus 9 has 2 zeros. This one says, confirm that the third degree polynomial function f of x equals x cubed plus 4x has exactly 3 zeros. Okay, so the first thing that I see about this is that I can factor out an x. I take out an x, I'm left with x times x squared plus 4. So if I set this term equal to 0 and solve, I just get 0. So here, x equals 0. And the multiplicity there is, what's the exponent on my x? Well, it's a 1, right? So my multiplicity is 1. Okay. So there's 1, 0. Now this one, I have to set this equal to 0 and solve. Most of the time we can do that in our head. Like here, I set it equal to 0 and solve, but I knew it was 3. So here I'm going to have x squared equals negative 4, square root. I get x is equal to plus or minus, don't forget the plus or minus, and the square root of negative 4 is 2i. If you haven't done the complex numbers notes yet, then you might get a little confused during this. Okay, so I get plus or minus 2i. So then the zeros here are plus or minus 2i. And the multiplicities on those are 1, but they're 1 each, right? 1 for positive 2i and 1 for negative 2i. So this also has 3 zeros. Right? So 1 for positive 2i and 1 for negative 2i. Okay, let's keep going then. Example 3 says, find and list all of the zeros in the function, then write the polynomial as a product of linear factors. So that product of linear factors, those are my parentheses, right? How many parentheses? So the first thing I see is that this is a 5th degree, so I should have 5 zeros, okay? And then the second thing I notice is I have no clue how to factor a 5th degree. I have absolutely no clue. So what we're going to do is we're going to graph this on our graphing calculator to try to find any zeros that we can. So go ahead and get out your graphing calculator and graph this equation, and then I'll show you what to do from there. All right, so on our graphing calculator, here's my equation. Oops, and I just realized I on an x there. So 12x plus 8, that would have changed my problem around quite a bit. And of course, my window is off. So we're going to let this graph, it's done. I'm going to go zoom 6, which takes me back to the standard window. And here's the graph. So first thing I see is that I have an x-intercept here at negative 2. And then I have a bounce at positive 1. Well, if it bounces, that means I count it twice, right? Because the multiplicity is 2. So what we're going to do is, I know since this is a 0, that my equation is divisible by negative 2. So I'm going to come here, and I'm going to divide using synthetic division by negative 2. So x to the 5th, the coefficient is 1. X to the 4th, there is no x to the 4th. X to the 3rd has a coefficient of 1. X squared has a coefficient of 2. X to the 1 has a coefficient of negative 12. And x to the 0 has a coefficient of 8. So the 1 comes down, and I multiply, and then add. Negative 2 times negative 2, so I multiply and add. And multiply and add. And multiply and add, and then I multiply and add. And I should get 0 here because I already know negative 2 is a factor. And by using the factor theorem, then, you know, if my remainder is a 0, then it is a factor. Well, I already know it's a factor, okay? So great. Now I'm going to do it again. I know also that it touches the x-axis at positive 1. So I'm going to divide it again by 1. So this 1 comes down, multiply and add, multiply and add, multiply and add, multiply and add. And again, I should get 0 there because I already know that 1 is a factor. Okay, that's great, but let's look at this graph. 1 actually has a multiplicity of 2. So you actually count 1 twice because it bounces off of 1. It has a multiplicity of 2. So it means I have to count it 2 times. So I'm actually able to do this again, but this time, and then I can divide by 1 again, a second time. So my 1 comes down, and I add, or multiply and add, multiply and add, multiply and add. And again, I should get a remainder of 0 because I know that 1 is a factor. Okay, and then so now I just have to look at what am I left with. I don't even need the q of x. We don't need that part. Okay, so what am I left with? I started with x to the 5th, and I divided once, and that gave me x to the 4th. Then I divided again, and that gave me x cubed. And then I divided again, and that gets me x squared. So this is x squared plus 0x plus 4. Or just x squared plus 4. Okay, so I know so far that f of x is equal to x plus 2, because it crosses the graph at negative 2, right? X minus 1, because it crosses the graph at negative 1. But it crosses the graph at negative 1 2 times, so it has a multiplicity of 2. Or you can write x minus 1, x minus 1. So then the last thing I have to do is just solve for this. X squared plus 4 equals 0. 0, there we go. Minus 4, x squared equals negative 4. Take the square root, and I get x is equal to plus or minus 2i. So that means another factor is x, let's take the positive one first, so minus 2i. And then another one is x plus 2i. And this is the product of linear factors. Meaning, if I were to multiply all of this out, I would get what I started with, x to the 5th plus x cubed, blah, 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 blah. Okay, so if I were to multiply all of this stuff out, I would get this answer. Okay, and that also tells me that the graph, the zeros of this graph, because it says find and list all the zeros, I have 1 0 at negative 2, so that has a multiplicity of 1. I have a 0 at positive 1, but it has a multiplicity of 2. I have a 0 at 2i, and that has a multiplicity of 1, right? Because the exponent on this parentheses is a 1. And then I also have negative 2i. And again, the exponent on the parentheses is 1, so that's a multiplicity of 1. Now, if we add up our multiplicities, 1 plus 2 is 3, 4, 5. I get 5. And what was the degree of the problem? 5. That should always be the case. Okay, so no matter what, whatever the highest degree is of your function, that is all your multiplicities added up. Fun stuff. Let's try another one. Shall we? So let's look. Optional examples. We're going to do these as well. Okay, first thing I see, I have no clue how to factor x to the 4th. So my first step is to go to my calculator and enter this into my calculator. So x to the 4th minus 6x cubed plus 22x squared minus 30x plus 13. Okay, and I'm going to hit graph. Okay, so again, I see that my graph is bouncing at positive 1, which means I can divide by positive 1 2 times because it's bouncing. Okay, so I'm going to take 1 and I'm going to use synthetic division. My highest exponent is 4 and the coefficient on that is 1. And then x to the 3rd is negative 6. X squared is 22. X to the 1 is negative 30 and x to the 0 is 13. So the 1 comes down. 1 times 1 is 1 and add. Right, then I have negative 5 and add. Then I have 17 and add, and then multiply and add. And again, I should get 0 because I already know that this is a factor. But since it bounces at 1, I can do this again. Okay, so 1 comes down, multiply and add. And we multiply and add. And then we multiply and add. And again, I should get 0 because I know that 1 is a factor 2 times because it bounces. Okay, so here I'm left with, I started with x to the 4th, but I divided once, so I got x to the 3rd, and then I divided again, so I got x squared. So I'm going to write it closer. So I get 1x squared minus 4x plus 13. And what really sucks about this one is that it's not factorable. So I'm going to have to use quadratic formula to solve it. And that's okay. Quadratic formula should be super quick for us now at this point. So negative b gives me positive 4 plus or minus the square root of negative 4 squared minus, I like to put my 4ac, 4 times 1 times 13 in parentheses. And this is all over, oh my god, I just drew a line through it, it's fine. 2a, so 2 times 1. Okay, so I have 4 plus or minus the square root. Negative 4 squared is 16, minus 4 times 1 times 13 is 52, all over 2. So I'm going to keep going. 4 plus or minus the square root. 16 minus 52, what is that, negative 36? Yep, negative 36 over 2. So I have 4 plus or minus. The square root of negative 36 is 6i over 2. And then when I actually simplify this, 4 over 2 is 2, plus or minus 6i over 2 is 3i. So those are my other two zeros, right? So I have a 0 at 1, another 0 at 1, 1 0 at 2 plus 3i, and 1 0 at 2 minus 3i. And that equals 4 zeros, which makes sense because my highest exponent is a 4. Okay? Now, when I write this as a product of linear factors, hopefully you have more room than I do, because we still have to write this as a product of linear factors. Okay, so I have x minus 1. It's always the opposite sign. And since I have that twice, I can square it. And then this is where it gets tricky, right? It's always x minus. And then one of my zeros is 2 plus 3i. And then I have x minus, the other 0 is 2 minus 3i. Okay, so this is 1 0, this is the other. And so then I can simplify this by just saying x minus 1 squared, and then x minus 2 minus 3i. I'm just distributing that negative, and then x minus 2 plus 3i. And that is the product of linear factors. And again, if I add up my multiplicities, right, positive 1 has a multiplicity of 2, and then 2 plus 3i has a multiplicity of 1, and then 2 minus 3i has a multiplicity of 1. So again, if I add those up, I get 4. Okay, I want you to try B. So go ahead and hit pause in the video and give B a try, and then when you're ready, hit play. Okay, so the first thing hopefully that you did was graph this on your graphing calculator, and it looks like this. And I see that it crosses the x-axis at 4. So I'm going to go ahead and divide this by 4. If you divided it by -1, you'll get the same answer in the end too. Okay, so don't worry about it. X to the third has a coefficient of 1. X squared is -2. X to the 1 is -7. And x to the 0 is -4. So my 1 comes down, and I multiply and add. And multiply and add, and multiply and add. And that makes sense that I get 0 because, because I know that 4 is a factor. Wow, sorry. X cubed, so I actually am ready to have x squared, right? I have 1x squared plus 2x plus 1, which is factorable, and it should be factorable pretty quick for us too. It's x plus 1 times x plus 1. Okay, so my product of linear factors, I have x plus 1 squared and x minus 4. So this tells me it crosses the x-axis at -1 twice, so it bounces at -1, and then it cuts through it, positive 4. And then so then my actual zeros are -1 with a multiplicity of 1 and positive 4 with a multiplicity of 1. Sorry. Whoosh, -1 definitely has a multiplicity of 2. Right? And that's it. That's what we're looking for, these two things right here. So hopefully that's making sense. If not, make sure you reach out. Let me know. We're going to move on now to kind of go the opposite way, right? If I'm given the factors, can I find the equation? And it's just multiplying, so it's not anything too scary, okay? So like example 4 says, find the 4th degree polynomial with real coefficients that has -1, -1, and 3i as zeros. Well, right now, that's only 3 zeros, right? 1, 2, 3. And this is a 4th degree, so it needs another 0. So the biggest thing that we have to remember is that if I have a complex or an imaginary 0, the conjugate of it is also a 0. So -3i must also be a 0. -3i must also be a 0. So if I go to write this, x minus 1 gives me a factor of x plus 1, right, a linear factor. And then minus 1 again gives me a linear factor of x plus 1. And then x minus 3i is a factor. And then x minus negative 3i, so because of the double negative, it becomes plus. So here's what my equation looks like as linear factors. But I want to find the polynomial, so I need to multiply this out fully. So I'm going to multiply these two together, which gets me x squared plus 2x plus 1. And then I'm going to multiply these out. Remember, these are complex conjugates. So hopefully we will remember that rule where we just take a squared plus b squared, right? Well, sorry, a squared minus b squared. No, I was right. It's plus. I was getting ahead of myself. So my a is 1. So, sorry, my a is x. I'm so out of it, you guys. I'm so sorry. My a is x, right? This first term is x. So I have x squared plus, and then my b is 3. And 3 squared is 9. Whoosh. Okay, we're getting through. Now I just need to distribute out. So x squared times x squared is x to the 4th. Plus 9x squared, right? So I did x squared times x squared and 9. And then 2x times x squared is 2x to the 3rd. 2x times 9 is 18x. And then 1 times x squared is x squared, and 1 times 9 is 9. And I don't have any like terms that I can combine, so I just get, and I'm going to write it in the correct order, x to the 4th plus 2x cubed plus 9x. Oh, just kidding. There's like terms to combine. The x squareds plus 10x squared plus 18x plus 9. And that is a polynomial of the 4th degree that has -1, -1, 3i, and -3i as its zeros. Okay, let's move on to the next one. We'll do one more together, and then you guys will do one on your own, and then we'll move on to the last page. So find the 4th degree with real coefficients that has -2, -1/2, and I. So if it has I, it also has -I. Okay? And then I'm also told that if I plug in 1 into this equation, I get -36. So it's being very specific about what it wants. But I want to talk about this really quickly. If I have x is equal to -1/2, and I want to solve this for 0, I'm going to multiply by 2. I want to get everything onto one side. So I multiply by 2, these cancel, and I get 2x is equal to -1. And then I add 1, and I get 2x plus 1 equals 0. So that is my linear factor. Okay, so I have y equals x plus 2 because I have -2 as a 0. Then I have 2x plus 1, which is how I got the 1/2. Then I have x minus positive I, and then I have x minus -I, so that changes it to a plus. Now, the only other thing is, and I'm going to get rid of this stuff, because they are very specific about a point, because I'm given a point that this graph goes through, that means that there's a specific a value in front here that they want me to find. So right now, I'm just going to leave it like that. Okay. The end of the day. And then we can figure out what this a value is later. Okay, so let's not worry about it right now. I'm just going to leave it here, and let's multiply these out. So if I multiply those out, I get 2x squared plus 5x plus 2. And if I multiply these guys out, x squared is x squared plus 1 squared is 1. All good? And I'm going to keep going. And I'm going to distribute this out. So I have 2x to the 4th plus 2x squared plus 5x to the 3rd plus 5x plus 2x squared plus 2. And I'm just going to quickly combine like terms and write this in the correct order. So 2x to the 4th plus 5x to the 3rd plus 4x squared plus 5x. My pen is starting to get real jumpy on us. Plus 5x plus 2. Okay, now from here, I need to try to figure out what a is, because once I know what a is, I can just distribute it in and then be done. Well, I know, put that back in, I know if I plug in 1 for x, I will get out negative 36. Does that make sense? Okay, if I plug in 1, I get out negative 36. I don't really want to plug in 1 to all of this because it's going to be kind of a pain, although 1's not that hard. So I'm just really quickly going to use synthetic division to figure out what I would get if I plugged in 1. So I have 2, 5, 4, 5, and 2. 2 comes down, and I multiply and add, and multiply and add, and multiply and add, and multiply and add. Okay, so if I plug in 1 into this, I would get out 18. So this tells me that a, I don't want this part. I'm so sorry, you guys. It's like the struggle is real today. Okay, so that tells me I get out negative 36 if I plug in 1, right? So this right here, if I plug in 1 to this parenthesis, I get 18. And I just figured that out by synthetic division. So now I can just divide by 18 and I get negative 2 equals a. So now I can say that y is equal to negative 2 times all of this, 2x to the 4th plus 5x cubed plus 4x squared plus 5x plus 2. And then last, but definitely not least, now I can just distribute the 2, or the negative 2, excuse me, and I'll have my equation. So negative 4x to the 4th minus 10x to the 3rd minus 8x squared minus 10x minus 4. So that is the equation of the polynomial that has zeros at negative 2, negative 1/2, I, negative I, and it also goes through the point 1 comma negative 36. Whoosh. Okay, so one for you to try here. Try B. It doesn't give you a point that it has to go through, so you don't have to find A. Okay, so just find the 4th degree polynomial that has these coefficients, and then when you're ready to go over it, hit play. Okay, so hopefully you gave it a shot, and you started with the linear factors. So I have x minus 2, or sorry, so I have negative 2 as a 0, so that tells me that I have x plus 2. And then I also have negative 2 again, so I have 2 of those x plus 2's. And then I have positive 3i, so x minus 3i. And then x minus negative 3i, so that changes it to a plus. Don't forget that whatever complex 0 you have, the conjugate of that is also a complex 0. Okay, so I'm going to take this and I'm going to multiply it out, which gets me x squared plus 4x plus 4. And I'm going to take this and multiply it out, which gets me x squared plus 9. And then we can multiply this out, so I have x to the 4th plus 9x squared plus 4x to the 3rd plus 36x plus 4x squared plus 36. So writing it in the correct order, I have x to the 4th plus 4x to the 3rd plus 13x squared plus 36x plus 36. And that is the equation of the polynomial that goes, or that has zeros at negative 2. It bounces off negative 2, and then it has 3i and negative 3i as its complex zeros. All right, let's keep cruising. All right, factoring a polynomial. Woohoo, right? So example 5 says, write the polynomial f of x equals x to the 4th minus x squared minus 20 as the product of factors that are irreducible over rational numbers, and as the product of linear factors and quadratic factors that are irreducible over real numbers, and in completely factored form involving complex imaginary numbers. Holy cow, what the heck does all of that mean, right? We'll go over it. No worries. So we're going to start with just the first one, which is the rational numbers over rational numbers. Okay, so f of x equals, and I want to factor this. Well, this is x to the 4th, but this is x squared. So what I'm going to do is I'm going to rewrite this where instead of x to the 4th and x squared, it's just x squared minus x. Because this is something that I can factor, right? It's x minus 5, x plus 4, and our factoring really should be that quick at this point. But since it's x to the 4th and x squared, that means that both of these are also squared. Okay, so you factor it just like normal, but those x's are squared instead. So over rational numbers, this is our answer. Okay? Then we want real numbers, so we're not allowed to have imaginary. So if I factor this over real numbers, if I set, let's get rid of this now. If I set x squared plus 5, minus 5, equal to 0 and solve, right? I get x squared equals 5, take the square root, and I get x is equal to plus or minus the square root of 5, because that doesn't reduce. So those are two factors. Those are two linear factors. So then I can say that this is really x minus square root of 5 and x plus, or minus, right? Square root of 5. Now, if I were to do the same thing with x squared minus 4, I would get a complex number. I would get an imaginary number, and I'm not allowed to have imaginary numbers in this answer because it only wants real. Okay, so I just have to leave it x squared plus 4. Then the last one that they want is complex numbers. So I'll write it out with any sort of number I want. So this is still x minus root 5, x plus root 5. And then now I'm allowed to have imaginary numbers. I'm allowed to have complex numbers. So now I can set my x squared plus 4 equal to 0 and solve. That gets me x squared equals negative 4. Square root, and I get x is equal to plus or minus 2i. So then now if I break that down further, I have x minus positive 2i and x minus negative, so plus 2i. So those are the three steps, right? So this is my answer among the rational numbers, right? No square roots, no fractions, decimals, things like that. Then this is my answer among real numbers, where I'm allowed to have any number as long as it's not imaginary. And then this is my answer in complex numbers, where I can have anything I want. I can have square roots and I can have imaginary numbers. So I want you to try these two examples, A and B. So let me scroll down. Optional examples, they're not optional. I want you to do them. And I want you to write them in the three, okay? I want you to find under the rational, right? Then the real, then the complex. And you're going to do that for both. And then when you're ready, you can go ahead and just hit play. All right, so for my rational, what I'm really looking at here is x squared minus 9x minus 22. How does that factor? And I get x minus 11, and then x plus 2. But since it's actually x to the fourth, both of these have to be squared. So it's x squared minus 11, and then x squared plus 2. So that is my answer among the rational numbers, right? Now, for ones that I would, in the real, this first parenthesis is going to give me the real. So x squared minus 11 equals 0. Add 11, I get x squared equals 11. Square root, and I get plus or minus the square root of 11. So that means under real, I have x minus positive square root 11, x minus negative square root of 11. And then this x squared plus 2 has to just stay because that would get me an imaginary number, and I'm not allowed to have imaginary numbers on that answer. I'm only allowed to have real. Okay. And then the last one, I'm still going to have my x minus square root of 11, x plus square root of 11, but now I am allowed to have complex numbers. So I'm going to do my x squared plus 2 equals 0. Subtract 2, I get x squared equals negative 2. Square root, and I get x is equal to plus or minus the square root of negative 2. Well, I'm not allowed to have a negative under that square root, so I'm going to bring out the negative and make it I, and then just leave square root of 2 since that doesn't simplify. So then this will be x minus I square root of 2, and then x minus negative, so plus I square root of 2. And those are my three answers. Okay. I guess you can move that up, it doesn't matter. Okay, similarly, over here, I'm really looking at x squared minus 4x minus 5. So if I factor that, I get x minus 5, and then x plus 1. But since it's actually x to the fourth, right, we have to have these as squared. Okay, so there is my rational. If I take this first part and set it equal to 0 and solve, I get x, well, it doesn't matter, I guess the order, plus square root of 5, and x minus square root of 5. And then x squared plus 1 will give me an imaginary number, so I can't have that in my real answer. And then the last one is complex, so I still have x plus root 5. X minus root 5. And then when I set x plus 1, or x squared plus 1 equal to 0 and solve, I get x minus positive I and x minus negative I. And that's it. Reach out if you're having problems with these or if you have any clarifying questions or anything like that, and we can go over it, okay? Last one we're going to do, we're actually not going to do B, so you can cross that off. Okay, but we are going to do A here. A says the concentration of a drug, f of x, in parts per million in a patient's blood x hours after the drug is administered is given by the function f of x. How many hours after the drug is administered will it be eliminated from the bloodstream? So how long after you're given the medicine will it then be out of your bloodstream? So the biggest thing, like, I have no clue what this graph looks like. Absolutely none. So I'm going to take my graphing calculator and we're going to graph it on our graphing calculator to see if we can come up with what it looks like. Okay, so negative x to the fourth. Okay, so let's bring up our calculator. Negative x to the fourth plus 12x to the third minus 58x squared plus 132x. Now I'm going to hit graph. And this is not helpful to me at all, right? I have no clue what this graph looks like. It crosses the x-axis at 0, but I don't know what these are. This just looks awful, okay? So I really want to see what the graph truly looks like. So let's look at our window and see if we can adjust this, okay? So remember that x is hours. So I'm not interested in negative hours. That doesn't make any sense. So I'm going to make 0 hours my smallest. And let's just stay with 10 hours. I would assume that a drug would be out of your bloodstream, like a prescription drug would be out of your bloodstream by 10 hours. I would hope. Okay. And then my Y minimum, Y is the concentration of drugs in parts per million. So again, I don't care about negatives, so I'm going to make that 0. And then my Y maximum, let's just go 150, 200, something. We can always adjust it. Okay, not super great, right? And what's going on here? Let me make sure. Did I type this in right? No, I did not. That's why I'm like, this doesn't look right. This is a plus. There we go. Okay, so that's definitely better. I probably don't need 150, but I can see it well enough. I don't really need to adjust it unless you want to. Okay. So here is when the drug is administered, and then the amount in your bloodstream increases, right, until it reaches the maximum. And then after a certain number of time, the amount of drug in your bloodstream then decreases. And I want to know how many hours after the drug is administered will it be eliminated from the bloodstream. So I want to know, what is this right here? I'm just looking at it. It looks like 6, but I'm just going to double check. Okay, so I'm going to go second trace, and I want to find the 0. I want to find where does this graph cross the x-axis. So it wants left bound, so I'm going to go to the left of it. when this x value, right, is to the left of it, and hit enter. And then right bound, I'm going to go to the right of it. I'm in the negative, so it's fine. Hit enter, enter, and it is in fact 6, okay? So just to, right, do this, the graph is doing something like that, and then this value right here is 6. So, and this is a word problem, so we need a sentence, right? After 6 hours, the drug will be eliminated from the bloodstream. So just whenever you're talking about real world situations or word problems, things like that, your answer should just always be a full sentence. Okay, that's it for 2.5. If you have any questions, make sure you reach out and let me know. Otherwise, good luck, nice job, and we'll see you later.